All right, we're going to finally wrap up Chapter 9 here, talking about Section 6, which is translations of trigonometric graphs, all right? And before we looked at simple trigonometric graphs, where all we changed was the amplitude and the period. In this section, we are going to talk about what happens when we not only change the amplitude and the period, but when we also change the horizontal and the vertical shift, okay? And so just to kind of remind you, A is amplitude, B is related to period. Period is equal to 360 over B. All right, and then over here we have the phase shift, which is H, and the vertical shift, which is K. And this is very similar to when we've learned about other functions, general forms of other functions. So let's just crash right into it. Quickly here, horizontal shifts are going to be dictated by H, as I just mentioned. If H is positive, you will have something like theta minus a positive number in here. So like theta minus 17 or theta minus 90, which would be a horizontal shift of 90 to the right. If it's a shift to the left, then you will have a negative value of H, and that negative value will make it look positive. So for instance, if you had y equals sine of theta plus 45, right? That would actually be a horizontal shift left of 45 degrees. Okay? So that's what I mean by kind of H is going to, it's a little bit deceptive, because if it's positive sign in here, S-I-G-N, if it's a plus sign in here, then that means it's going to be shifted left 45, and if it's a minus sign, it's going to be shifted to the right, okay? The vertical shift is more straightforward because the sign doesn't, you have to worry about the sign. If K is positive here, then it's going to be shifted up. If K is negative, then it's going to be shifted down. Okay, so K kind of acts as you would expect it to. The midline is going to be whatever the K value is, and that's going to be the line that cuts the graph in half. We're just talking about sines and cosine curves here. All right, so that's going to be the line that cuts the graph in half. That's also going to be equal to the vertical shift. Okay, so notice that K here is the vertical shift. Okay. Sorry, that's pretty poor penmanship, but that's the vertical shift. All right, now let's do some graphs here, okay? So before I go and graph this, now you can go right to your calculator, but it can be honestly easier to sometimes just find the stuff and then graph it out. So the period is going to be equal to 360 over B. And B, if there's no number written out here, then B is 1. Okay, so our period will be equal to 360 over 1. That's 360 degrees. Okay. The amplitude is going to be the number out in front of sine. If there's nothing written out there, it's 1. So the amplitude in this one is 1. The phase shift is going to be whatever the H value is. It's going to be positive 90. Again, horizontal takes the opposite of whatever this sign is. So that's going to be shifted to the right 90. And the vertical shift is going to be whatever numbers I added out here, and that's 0. Okay, so vertical shift of 0. So if the period is 360 degrees, and I've left this blank so that we can kind of pick our scale here. So I'll just put positive 1 and negative 1 here, because there's no vertical shift, so that's fine. And then you can look at the graph, but basically what I'm going to do is look at the period at 360, and that means that I want it to complete one cycle every 360 degrees. So maybe I put 360 degrees out here. There's going to be an important point halfway. It's 180. And halfway from 180 to 0 is going to be another important point, so that's going to be at 90 degrees. Okay, so that gives me some sense, and then I can put this other value here that's at 270. This gives me some idea of where the important points will be on the graph. Now, of course, you can go straight to the graph, right? But knowing what the period is helps you set the window so that it's in a way that kind of makes sense. So we can maybe go from negative 90 to 360, and we can put this graph in the calculator. So it would be sine of x minus 90. And graph it. Okay. Now you can see that it only goes up to 1, it goes down to 1. You can see that there's an intercept right here, and you can go to your table to figure out what that is if you want. So it's at 90, comma 0. So there's an x-intercept here at 90, comma 0. And then you can get other points as well. So like 180, comma 1, there's a maximum. 270, comma 0. And then a minimum at 360. and then a minimum at 0, at -1, and then if we go out to -90 here, then we've got another intercept, and you can start to kind of see what this graph is going to look like. Okay, so there's the piece of the graph. Now, if you've got a different, usually like in the worksheet, so if you look at the worksheet here, the scale will be given to you, so you won't have to pick it. But that's basically what's going on there. All right, so let's skip this one, because the process is really sort of the same in that one. And let's go on to one that's a little bit more complicated. So let's go on to the third example here, the third graph here. All right, but there's a little bit more going on. So the period is always 360 over b. So it's 360 divided by b. Now b in this case is 2/3, so 360 divided by 2/3. You don't want to probably use your calculator for that. And so it's going to be 360 divided by, parenthesis, 2 divided by 3. That's 540 degrees, so the period's 540. Okay, so we got that. The amplitude is whatever number is out in front, and we take the positive of it. It's 3, so the amplitude is 3. The phase shift is going to be positive 180 because it's minus 180 here, so positive 180 degrees. And the vertical shift is 2. Vertical shift is 2 there. Okay, and I'm not even sure that we really need to graph it. I'll put it in the calculator just to show you how you should type it in, just so that you don't make any mistakes there. But sketching the graph, again, we gave you the scale on the worksheet for each problem, so so we don't need to build our own scale, nor do I think we need to practice that too much. So here is the curve. It is 3 sine of 2/3, so I'm going to be careful here. I'm going to go 2 divided by 3 in parentheses, and then notice I'm leaving that parenthesis open, x minus 180. Okay, so I've closed off all the parentheses here, so I've got 2/3 times x minus 180 all in the sine graph, and then plus 2. Of course, if you put this in Desmos, it's going to look a lot nicer, and this is what the curve is going to look like. Okay, so you can see here, maybe we don't have quite enough to see the whole thing, so maybe we take that max out to 720, so we can see more of it. You can see the period is 540, so, all right. Again, the graph is going to be a little bit nicer on Desmos, so I'll just try to show you kind of the worst version, and then the Desmos version is going to be a little bit better. So it would be easier to find the important points. As usual, you can flip to your table, and if it's set to go by 45s, you can get most of the important points usually. Okay? All right, the last thing I want to talk about is finding the equation from the graph. And so that's the last example there. And as I say that out loud, I don't think it's actually something that we need to do, but just in case it shows up on a quiz or something, let's just talk about it briefly. So if I find the minimum here, first thing I'm going to look for is the midline, by the way. So find the minimum here, that's at -3. The maximum is here at 5. All right, so if it goes from -3 to 5, then half of that would be 4. So I'll go up 1, 2, 3, 4, and there's my midline. Okay, so if I know the midline is at 1, then k has to equal 1, because the midline is always equal to whatever k is. This is going to be a cosine curve because it starts at a maximum. Sometimes sine curves start at maximums, but you get to pick here, so I would pick a cosine curve. And then the horizontal shift is going to be 0 because cosine starts at a max, and that's not shifted at all. That maximum is not shifted at all. The amplitude, A, is going to be equal to whatever the height of the curve is from the midline, okay, and that is going to be 4. The period for this is going to be, let's see, from maximum to maximum here, which I believe is going to be 360. Looks a little bit off there, but I think that's supposed to be 360. So if the period is 360, then 360 equals 360 over b, because remember we need the b value, not the period. So we'll just solve this equation real quick. Times the sides by b. I get b times 360 equals 360, and b equals 1. And there's no horizontal shift, so from that I can write my equation. Y equals cosine, 4 cosine, b, which was 1, and then no horizontal shift, so just cosine of x, and then plus 1. So there's my curve. You can always check it with the in the graphing calculator. But going backwards, even if it doesn't show up in the assignments or the assessments, is just a good way to give you an idea of what's going on in the graph in kind of the backwards direction. Okay, and that is pretty much it for section 6. As I said, in the worksheet that you're given the scales. Okay, and so you don't need to, you can just kind of make your graphing calculator match the scale. So this one we'd go from maybe -90 to 360, for example, on the x's, -2 to 2 on the y's. And that wraps up section 6.